Alright, we're going to practice some predicting products of chemical reactions and identifying reaction types. So the first one here, we've got beryllium hydroxide. We only have one reactant, so that's a pretty good indicator this thing is going to be a decomposition reaction. So, using my knowledge of decomp, I know of four types. A simple decomp, a carbonate, a hydroxide, or a chlorate. This one happens to be a hydroxide. So, first thing we should probably do is write the formula for beryllium hydroxide. So I look at beryllium. Beryllium always has a charge of 2+. Hydroxide is OH and it's 1-. So when you write the formula, Be, and then the 2 comes down behind the hydroxide, so you need it in parentheses. Alright? Well, in my knowledge of hydroxides, I know that they turn into two things, a metallic oxide and water. I'm going to take care of the water right away since that's easy. Okay, so my metallic oxide, I have to look and see which one of these things is a metal. Well, it's going to be beryllium's the metal. Since beryllium's 2+, I know oxygen's always 2-, and so it's simply going to be BeO. Alright, I want to name these compounds. Beryllium oxide, and then plus, you can just say water. You don't have to say dihydrogen monoxide. We need to check to make certain the equation is balanced. We've got one beryllium on each side, 2 oxygens. There's 2 oxygens here, 2 hydrogen, 2 hydrogen. This one's already balanced. Okay, for the second one, we've got bromine and calcium iodide, and so type of reaction this more than likely is I have a compound and an element. Excellent chance this is going to be a single replacement. Sometimes there's synthesis, but I'm not going to give you any examples like that because you'd have to have a little more knowledge than what we have. So let's start here. Bromine's one of those Brinkelhoff. It's diatomic, so it has to be Br2. Calcium is always 2+. Iodine is always 1-, so it's going to be CaI2. Alright? And so, with single replacement, like replaces like. So if the lone element is a metal, it'll try to replace the metal in the compound. If it's non-metallic, it'll try to replace the non-metal. Since bromine is non-metallic, it's going to try to replace the iodine in there. Alright, and so what's going to happen, we're going to have calcium bromide. And so since bromine is 1-, calcium's still 2+, it's CaBr2. Iodine gets kicked out. It's diatomic, part of Brinkelhoff, so it's I2. This one happens to be balanced already. And so we're going to write the names of the products here. We have calcium bromide plus iodine. When these elements get kicked out of the compound, they're no longer named like anions, they just get the element name. So notice it ends with INE, not ide. Okay, the next one we have aluminum and platinum 2 nitrate. So once again, an element in a compound, this is another example of a single replacement reaction. We've got aluminum, and then platinum. This Roman numeral 2 tells us that platinum's charge is 2+ in this instance. And so I'm going to put platinum here, and then nitrate is NO3, and it's -1 always, so it's PT NO3 parentheses 2. Once again, we have like replacing like. And so since aluminum is a metal, it's going to try to replace the platinum. Aluminum's charge is always 3+, and nitrate is 1-, so it's going to become Al NO3 parentheses 3. And then the platinum is just kicked off here by itself. Alright, so we're going to have to do some balancing on this one. I'm going to go ahead and balance the nitrates first. I have 2 nitrates as reactants and 3 as the products. Well, the common factor of that's going to be 6. If I flop a 2 here, nitrate turns into 6. Flop a 3 over here, nitrate turns into 6. Now all I have to do is balance the metals, put a 2 in front of the aluminum, 3 in front of the platinum, and we're good. I'm going to name this aluminum nitrate plus platinum. And you don't have to say platinum 2. It's when it's just metallic platinum, just call it platinum when it's not in a compound. All right, for number 4, we have sodium chromate and barium phosphate. So in this instance, we have 2 compounds. Once again, it could be synthesis, but we're not going to do any that are like that. Any synthesis we do will be just 2 lone elements combining. This one, it's going to be an example of a double replacement. So we need to write out the formula here for sodium chromate. Sodium is always 1 plus. Chromate is CrO4 and it's 2 minus, so the 2 comes behind the sodium. There's our sodium chromate. And then barium phosphate. Barium, I look at it, it's always 2 plus. Phosphate is 3 minus, and so the 3 comes down behind the barium. PO4, and then the 2 goes behind the phosphate. So crossing the charges. I mentioned before that this is kind of like in algebra when you FOIL things, the first, outer, inner, last kind of business. So everybody's going to switch dance partners. This sodium, the cation of the first is going to want to go with the anion of the second. And then vice versa, we have the cation of the second. It's going to go with the anion from the first one. And so, sodium, still always plus 1. And then phosphate is 3 minus, so it's going to be Na3PO4. And then what's left over is barium chromate. Since barium is 2 and chromate's 2 minus, it's just going to be BaCrO4. All right. In order to balance this one, more than likely, let's see here. 3 bariums, if I put a 3 here, that's going to put 3 bariums on both sides. I have 2 and 3 sodium, so common factor is going to be 6. If I flop a 2 in front of this one, that's going to give me 6 sodium. I'm going to place a 3 over here. Now I have 3 chromates on both sides. 2 phosphates, that appears to be balanced. Now we just have to write the word part of the equation. Sodium phosphate plus barium chromate. All right, so on this next one, we've got zinc acetate and sodium chloride. So once again, 2 compounds, it's going to be double replacement. Zinc is always 2 plus, and acetate, C2H3O2, is 1 minus, so we need parentheses and a 2 here. Sodium chloride, sodium's 1 plus, chlorine's 1 minus, so it's NaCl. Once again, we're just going to do the switch and dance partners. Zinc is going to go with the chlorine. Since zinc is 2 plus, the 2 goes behind the chloride. And then we have sodium acetate. Sodium is always 1 plus, acetate is 1 minus, so there's nacho, sodium acetate. Now all we have to do is balance. So let's see, I have 2 acetates and 1 acetate. If I flop a 2 there, that fixes that. Now I have 2 sodium and 1 sodium. Flop a 2 here, that also balances the chlorides. We're balanced. So I have to name the products. Zinc chloride, I don't have to mention zinc's charge because it's always 2, plus sodium acetate. Okay, lithium, bromide, and chlorine react. All right, so this is going to be another single replacement because I have a compound and then I have an element. Lithium's always 1 plus and bromine's always 1 minus, so it's LiBr. And then chlorine, it's got to be Cl2 because of Brinkelhoff. All right, and once again, like's going to try to replace like. And so the chlorine's going to try to replace the bromine. The nonmetal's going to try to replace the nonmetal. Lithium's still 1 plus and chlorine's 1 minus, so it's LiCl. And then bromine is part of Brinkelhoff and it's Br2. You may be saying to yourself, Self, why on earth, why do we have a 2 here with a bromine but not here? Well, because over here it's not by itself, it's with lithium. Only when the diatomics are all alone are they found in pairs. To balance this one, pretty straightforward. 2 here, and we're good. And then let's finish the word equation. Let's just say like 2 yield lithium chloride plus bromine. Okay, that first thing is sulfuric acid, and it's reacting with potassium hydroxide. So once again, we have 2 compounds. This is going to be an example of a double replacement. So I'm going to write my formula for sulfuric acid, H2SO4, and then potassium hydroxide. Potassium is always 1+, hydroxide is 1-, so it's KOH. Once again, we're just going to be switching dance partners, so the H is going to go with the OH. Don't bother the fact that it's H2. We fix that with balancing later. And so H and OH, or you can write it as water, because that's what it is. What's left is potassium and sulfate. Potassium is 1+, sulfate is 2-, so it's K2SO4. All right, and then, let's see, let's balance this guy. If I flop a 2 here, potassium becomes 2 on both sides, hydrogen becomes 4, so if I put a 2 here, that should balance at 1, 2, 2, 1. And I'll just put the name of the products over here. So we have water plus potassium sulfate. This is a special type of reaction we're going to learn about later. It's called a neutralization because sulfuric acid is an acid, potassium hydroxide is a base. When acids and bases react together, they form a salt, this is a salt, and then water. All right, so here is another decomp. We know it's a decomp for 2 reasons. 1, it's only got 1 reactant. 2, it says the word decomposes. So let's write our formula here. Iron 3 chlorate. We know iron is 3+ because of this 3. Chlorate is ClO3 and it's 1-. When you cross them, it's Fe, ClO3 in parentheses 3. You have to have the parentheses, otherwise it looks like 33. Okay, so looking at my decomposition, is it a simple one? Is it a carbonate, a hydroxide, or a chlorate? It is a chlorate. Well, chlorates decompose into metallic chlorides and oxygen. Let's do the oxygen part first. That's easy. It has to be O2 because it's diatomic. And the metallic chloride, well, the metal here is going to be iron. The charge, the oxidation state of iron, is not going to change from one side to the other. So since it was 3 as a reactant, it's going to be 3 as a product. And so it's actually going to be iron 3 chloride. So iron is 3 and chlorine's 1-, so it's FeCl3. Let's see. In order to balance this thing, let's look at the oxygens. We've got a total of 9 on one side and only 2 on the other. Let's see. 9 and 2. If we, it's going to be 4.5, but then we got to double some stuff, don't we? Let's see. So 4.5, let's just double it, and this is going to become 9. And so we need to put a 2 in front of here, right? And that's going to make 9 oxygen. Then we've got a total of 6 chlorines. So if I put a 2 here, that balances the chlorines. 2 irons, and I think that's good as far as I can tell. Let's see. And so what's it going to make? It's going to make iron, and you have to still put the Roman numeral 3 there because it's in a compound. Iron 3 chloride plus oxygen. Magnesium and chlorine gas react. Don't get upset about the word gas in there. People see the word gas, they're like, I don't know what to do. Well, if it hurts your feelings, go like this. Okay? It's just magnesium and chlorine. Chlorine's found in its gaseous state. It's just an extra word. Here I have 2 elements, And so because I have two elements, that's a really good indicator that that thing is going to be a synthesis. And so I need to write